So where are we, Kent? So that's the picture of where Kent is in the UK. You can see it's very close to Europe. It's only a very short distance from Calais and the Pas-de-Calais. So what's the challenge? COVID hit Kent particularly badly. I don't know whether it's because it's where a lot of people influx from and they come by boat, etc., and they brought the virus in with them. I don't know, but we've been hit particularly badly, and we were the 4th highest in the UK for care home deaths, with a very high number of deaths in care home. 425 people died in Kent care homes, and one care home that I've been talking to lost 50% of its residents due to COVID-19. And the reason for this is that people were being discharged from hospital into care homes without any testing done on them, and then they brought the COVID virus into the care homes where there were many old and vulnerable people. So the NHS in Kent, and in fact in the whole country, the NHS was asked to get testing running and working as soon as possible. And the COVID test database that was built in East Kent was built in little more than a day because everything was really rushed. And all it does essentially is stores the user's mobile phone number and then the test result, and then they send an SMS message back to the patient to say this is your result. So the whole database is test-centered, not user-centered. So if the user has a test a month later, it'll be a completely different record in the database, and there'll be no knowledge that this user had a test a month ago and he's had a different test today. This is actually a picture of the test centre at my local hospital, where you drive in and you get a swab done on your throat, and then you get the result sent. And this is actually my wife had to go for a test, and this is actually the results that came through on the mobile phone. And she had to click on the URL, and then she got a page which said that you can see my wife's called Maggie. That she was actually negative, which was very, very fortunate. We weren't infected. So that's the situation today. Now, while that was all going on, as I said in my introduction, during 2019, we were funded to develop an application-independent verifiable credential infrastructure. And when COVID struck, I was actually stranded in New Zealand. That's why there's a picture of Hong Kong Airport. I'd gone out to New Zealand to give a talk about the research we've done on verifiable credentials to the OWASP group in New Zealand. And when I got there, I was stuck, in fact, in New Zealand for 3 months, as it turned out. And so while we were there, we developed this COVID-19 proof of concept, which we thought might help people. And then when I got back to, well, in fact, while I was still there, I started talking to the medical staff at the university to see if we could turn this into some sort of application demonstrator for them. And the following use case was proposed to us. Hospital patients being discharged to a care home, as because there was such a high number of deaths, they want the patients to be tested before they go, and we want them to have a COVID-19 certificate to take with them, because today they have a test, but where their test result goes is not always immediately obvious. And when they go to the care home, when the patient might turn up, they say they have to phone up the hospital or get an email or discharge letter or something. And sometimes they won't accept patients because they don't have the knowledge about their COVID status. So we hope that if they have a COVID certificate to take with them when they go, then the care home will be able to prove that their COVID status and act accordingly. So this is a picture of our application-independent verifiable credentials middleware that we developed at the university. So I'll explain the components to you. Here we have a VC issuer. This is the software that issues verifiable credentials. They could be an age credential, a right to work degree credential, or whatever address. And they are transferred to the holder in his wallet. And then the holder will construct them into a verifiable presentation when asked by a relying party over here. And the verifiable credentials will go in an actual verifiable presentation over at the application layer to the verifier. And the verifier will then call our API and pass the verifiable presentation to it, and it will verify the crypto, and it will say that this user satisfies your policy for access to your resource, and these are the attributes that we've verified from the issuers. Now, the interesting thing in this infrastructure is that this link here we established with FIDO 2. so that when the user registers, and I'll look at registration in a minute, when the user registers, a FIDO key pair is established along this link. And this allows the user at any time to go back to the issuer and get the very latest copy of his verifiable credential. And what he holds in his app when he doesn't need a credential is what we call a skeleton. It's got the skeleton contents, but it's not actually a verifiable credential. The verifiable credential is created on demand whenever a verifier wants one. And we have an API that we've published. We've published our APIs in the W3C credential group. This issuing API is designed to connect to an LDAP or any other corporate directory service that contains the details of the people. So if it's, for example, the Vehicle and Driving License Authority, they'll have details of the cars and the owners. And so we can then pick it up through this API to produce a verifiable credential about it. So if it's a local council, it might have your name and address and your council tax details, etc. If it's a university, it will have your degree awarded and the details already stored in its database. So we've got a nice API that picks it up in JSON, gives it to our issuer, which then packages it up as a standard verifiable credential. So it's quite unique as our system because it doesn't use blockchains or persistent DIDs. Instead, it uses FIDO2, as I've said, to authenticate, and then it issues short-lived irrevocable VCs at the time they're needed. So in other words, it's operating similar to SAML and OIDC rather than X509 and VC blockchain systems, which are long-lived and revocable. Ours are short-lived and irrevocable like SAML and OIDC. What are the advantages of this? Well, the advantage of user consent. The user, when the user registers, we get him to consent to the attributes that potentially can be issued so that the issuer knows that the user has consented to these attributes being released in verifiable credentials. So we now make it very easy for an issuer to comply to GDPR because he will only issue attributes in verifiable credentials that the user has consented to. And selective disclosure is automatic because the verifier says which identity attributes it needs, and the issuer only puts those that are needed inside the verifiable credential. And the user agrees to this and sees it. So again, it's very easy for the verifier to conform to GDPR because he can publish his policy. He can say, this is my policy for which attributes I need in order to perform this transaction. And then they say, yeah, that's totally GDPR compliant. And then he will only ever get those attributes in the verifiable credential. And no complex, possibly privacy leaking revocation lists are needed either. And no usernames and passwords are needed after initial authentication, because from then onwards we use FIDO2 to talk between the user's device and the issuer. So now we're looking at how do we go about integrating the two systems. Well, there's clearly going to, at the registration stage, there's going to have to be some sort of authentication where the user puts in some sort of private details to authenticate to the test center. And then what comes back, this is the laptop version, what comes back are all the details of the COVID-19 certificate that will be potentially available to him. So he has to consent to these. And you notice he can select all of them or individual ones. So for example, if I decide that I don't want my address to ever appear on my COVID-19 certificates, I will not tick address. And then all that will ever be published will be my date of birth and name and my certificate details. The certificate details themselves, the consultant in charge has said he wants 3 possible values to go in there. Whether he's developed any, or he or she has developed any antibodies, and the only response there is positive or negative. Whether the patient is currently positive to the virus or not, and that would be positive or negative, and whether the person's been vaccinated or not. So we're already planning for vaccination certificates because we know that vaccines are going to be available later this year and possibly open to the public next year. So we'll be able to publish vaccinated certificates which say that the person has been vaccinated. This is the iPhone mobile phone view where the certificate skeleton comes through, and the user can tick and accept all the different parts of the certificate that he's prepared to accept, and then you can see at the end he consents to them being released to him. Now, when it comes to presenting, he will go to a website that wants some verifiable credentials in order to access it. And in this case, we draw a mock-up of Nightingale Hospital, for someone who might want to work on the critical care ward. And in order to work on the critical care ward, you need to show that you're COVID immune, or you've been vaccinated, or you're not obviously infected at the moment. So when he clicks on Submit Certificate, what our system does is it authenticates the user to the issuer, gets the certificate details that the hospital has asked for, and then says to the user, choose which ones you want to present. Now, in this case, there's only one, so he's only got one choice to make. And when he makes that choice, it displays the attributes that the hospital has asked for. And this will be a subset of the ones that he previously said are okay. And when he's happy with that, he can submit it, and the hospital will get those details. Now, what's the disadvantages of this system? Well, users have got to have an electronic device, a mobile phone or a PC or something. And most people entering care homes don't have either. And some may have dementia, so they cannot even read or write English properly, and some may be foreign, etc. So how can we make our system that works for laptops and works for mobile phones, how can we make it all inclusive? So our proposal is that we'll create paper-based certificates containing the details, along with a QR code, which will have the cryptographically protected VC in it, and a pictorial representation for those who cannot read or write English. So if they've got a paper certificate with a symbol or some picture on they know, and they're asked to present it, they'll be able to present the right one, because each certificate will have a different picture on it, and they'll know which one is wanted. And then an optional portrait picture of the patient as well, which you'll look at in a minute, and the whole can be printed out. So there's no expensive equipment needed by issuers. They just need a laser printer, and they can print out these certificates and give them. The complexity is all in the verifiable credential infrastructure, which will validate the contents and the cryptography and tell the verifier that this certificate is correct, it's not fraudulent, and it's not been revoked. So this is a proposed paper certificate example. You can see here we've got some sort of picture which the user will recognize as well. This is my COVID certificate. We've then got the details with a QR code which will actually validate the cryptography on it. And now we've got also a picture of me with another QR code. Now, why have we got these separate? The idea is this is a sort of mini selected disclosure. So the user can decide to disclose just the written details, or to disclose the picture as well, and they would be separate. You would have to allow the recipient to scan both QR codes in order to validate the picture of yourself. So what are the trade-offs? Of course, the trade-offs when we go down here, we've got privacy versus all-inclusivity. Paper is all-inclusive, everybody can have it, but it doesn't easily allow selected disclosure. So what we've done in our mock-up is we've allowed selected disclosure of the main details and of the picture to be a separate disclosure. Security, yeah, paper's easily photocopied, long-lived and transferable. So there's some loss of security to our electronic version there. So and there's also complexity adding, because now we need to build in a revocation infrastructure, etc. So there are some trade-offs there. So what are we still going to do? Well, we're going to work with the stakeholders to determine what final design do you want for the paper-based certificates, and what are these optimal trade-offs in security, privacy, and usability? For example, do you want the picture to always be on the credential or not? Is that important to you or not, etc. So we've got to do that. So that's where we're at. And I think that's the end of my presentation. Thank you very much.